everyone, welcome to another update on Kwyll. Lots been happening since the last video. I'm sorry that it's been a little while, but things have been quite busy, both on Kwyll and in other things, but lots to talk about. So most of the work I've been doing, as I've sort of hinted at in the last couple of videos, is going to be now on the Spectrum side, trying to make it as fast as possible, use as little memory as possible to give as much space for the games designers to work within. So I'll go into a bit more detail on some of those things, but also as I've been working on those things and talking to the people in the Discord, a few other quality of life or nice features have sort of been raised and requested for Kwyll itself. So there are a few things I'd like to go over on this video that have been changed in the editor. Some new features, some nice things that would be generally quite useful. So I'll go over those first, and then I'll go into a little bit more of a detailed breakdown at the end of the work I've been doing on optimization for performance and memory. But before I go into that, one thing that I've realised I've been remiss in not mentioning is the people who support this project through Patreon and Ko-fi. I've had a few people now both kindly providing funds through Patreon and Ko-fi, which is very, very welcome, but more importantly maybe is interacting and working with me on the Discord to make sure that Kwyll becomes something that's actually useful to the people who want to use it. So it occurred to me thinking about putting this video together that one of the things I haven't done is call out those people who have been supportive in many different ways on Kwyll. So I want to just list those names, and I'll list them up here on one side or the other in a moment, and say thank you to everyone for all your contributions. It's humbling that people are willing to give their hard-earned cash for this project. It's more important to me that enough people are willing to contribute in the way that they are, both monetarily and in terms of their time and their focus, because it tells me that there's at least some interest in this project going forward, and that's what's keeping me going, keeping me spending as much time as I can on it, making it as good as I can, getting it into shape, ready for a release. Once again, thank you to all the people who are listed here for all their contributions. Okay, so first of all, I'll go through the basic changes. So there's as I say, there's an area that requires a little bit more detail around optimization and how it works on the Spectrum, but there's also a bunch of other smaller changes since the last video. So I'll go through those in no particular order first, and then we'll spend a little bit more time on the optimization and how that looks. So if I switch to the editor, so we can see. So one of the things that has always been a bit of a problem is that the tools, the editor tools and the simulator in particular were not taking any notice of masking. So you know that there are different types of mode that you can render sprites with. These sprites in particular have a mask layer, so the checkerboard pattern indicates where the background is going to show through. And in the editors, when you're moving objects around by dragging and dropping them, and when you're in the preview, that wasn't being respected. So if I show what it looked like before, I can just switch this to load mode, which is effectively what it was doing. And then if I go to preview and move, you can see that it just blacks out the area behind the sprite with the background color and then draws the sprite over the top. That's what it was doing before, which isn't ideal. And the same in here. So where you've got an object that you're dragging around, it would do the same thing. So now if I switch the object itself back to mask draw mode, and we go to the map, you'll see straight away that it respects the mask layer and masks out the area that the sprite should draw over. And similarly in preview, when you walk over things or walk over here, it will use the mask. The next feature or change is not something I can demonstrate, but I can explain it very quickly, and it's probably important to some people, but not so much to others, is the inclusion of a Linux release. So up until now, all the early access releases that the Patreon and Coffee subscribers have had access to have been Mac and Windows. And only very recently did a new subscriber come along who requested Linux support. It was always on the cards that I would do it, but this sort of pushed it up the priority list a little bit. So now I can deliver a Linux version, and it all works. The toolchain works. So I can show you what that means if I go to here, which is the export. One of the features, one of the elements of exporting is it needs a toolchain, which is the Z88DK compiler and various bits and pieces, which I built a custom version of. So you can see here I'm on a Mac OS M1 machine. So it's identified and installed the toolchain for Mac OS. If I go to the download button, it will identify my system as Mac OS Apple. Hopefully the system I put in place for identifying your machine will identify a Linux machine if you're on a Linux machine, but if not, these are the machines that we have toolchains available to download for. So you can see we've added Linux, AMD and Intel here. It doesn't do Linux on anything other than x86, but it should identify either of those happily. Now the next feature on the list is listed here as non-integer variables. So basically, if I go to if I go to the player logic, for example, anyone who knows the logic at this point will know that we've got a number of different wire colors. We've got these variables over here, and we've got a number of different wire colors. Now typically numerical values, integer numerical values, are represented as a green wire that go between the various nodes that expect number values. Blue is an object reference, so it's a reference to a room object or an object on the map, and magenta is a reference to a location on the map. So these three colours, the white ones are just the flow for execution, indicate the type of data that's being transferred from node to node. Now, up until now, anything relating to variables only worked with numerical values. You had to use numerical values to store. You could only store numerical values into a variable, and you could only use the value of a variable in a node that expected a numerical input. So for example, you couldn't use the value of a variable in a ref input port because it expects an object reference. So this was an unnecessary restriction, because internally on the Spectrum at least, an integer value or a numerical value is a 16-bit integer, and a reference to either an object or a location is also a 16-bit integer. It just happens to be a pointer. So they take up exactly the same amount of space, which means that the variables on the Spectrum have enough room to store any of those three types. So it seemed logical to extend the capabilities of variables to allow them to store any one of those three types and provide them back, which means you can do things like in this object hit, for example, you're getting a reference to the object that was intersected. You could now potentially store that into a variable for later use, so you could tell what the last object you hit was, and you can hold that for as long as you need to. So if I just load up very quickly a sample that demonstrates what this looks like, I go to here and we go to our global logic. So what you can see, where you would normally have these perfectly magenta or perfectly green wires, if you're taking a variable or a value of one type and putting it into a port of another type, providing Kwyll has determined that conversion is valid, it will show up as a gradient wire. So you can see this is going from a magenta location reference into the value for a variable, and this one here is taking an object reference and putting it into the value. And then further down here you can use these. So this is a very simple test. It's basically it's always putting the current location into one variable and a particular object into another variable. And then down in a second always flow, if the fire button is pressed, it will read out that object variable again and move the object. So we're not using get global object here, we're using the variable value. And this could potentially be much more involved. The way that you get this value and put it into the variable could be from a collision detection, it could be from a property set on another object or on a room, or through other parts of the logic. And all this needs to know is that the value in object test is a variable of type object reference, and it will use it as such. So when we preview this and I hit the fire button, it just moves that object along. Next one's really simple. So basically we have objects. If I load up something with a bit more interesting information in it, so we've got the player object, and we've got a number of different sprite animations. Up until this change, it would always just, if you have a sprite animation at all, it will use the first one when the game starts and restarts. But now so in the map, for example, we have our player object, and there's been a lot added to this and changed in this object properties. I'll go through some of the other stuff later, but the one that matters here is this initial animation. So you can choose which animation you want to start with and what rate, and when you start the game, that's the animation that will be chosen, and when you hit reset, or you push a reset, run a reset game logic node at any point in your game, it will go back to this, so you've got a known state. Next one's difficult to demonstrate, but I'll explain it. So up until recently, I have been storing certain critical information in a local kind of preferences or state file on your machine that's unique to Kwyll. It stores things like if you hit the load button, the directory that you last loaded a file from, so you can always get back to the same one. It's a lot easier than having to find it each time. And similarly, when you're doing an export, it'll store things like this in there so that the target directory for your export is consistent and you can export very quickly to the same place. Now it stores a whole bunch of other stuff around the GUI. So primarily it will store the window position on your screen, so where the window is, whether it's on screen 1 or screen 2 if you have multiple screens, and the size. So if you go full screen, it'll record that. If you just make it smaller or bigger, it'll record that. But also within each of the editor areas, you have usually a bunch of splitters that allow you to rearrange how the space is organized, so that you maximize it for your own personal preferences. It'll store all of those as well. So if you go to the sprites, you can give yourself a little bit less space and more for your sprite map and so on and so forth, and arrange it how you feel comfortable. And when you exit, it will store that information and restore it. So next time you load, it should load Kwyll up and position the window in the same place it was at the right size, and all of these splitters will restore to their previous positions. I plan to add more to this over time, so things like which tabs within each editor and various other things, but for now it just stores the basic layout. Okay, so on to the next one on the list, which is being able to set animation keyframe details directly in the pop-up. So I've got path test open, which is a sample file with some keyframe animation. So if you go to the room and the single object, you can see we've got an animation on here with some keyframes. And if we go into edit mode and select one of these keyframes and right click, you'll see you have some information about that keyframe. Now what this used to have was there would be no F on there at all, I don't believe. There certainly wasn't the ability to edit the X and Y position, they were just shown. So what I've included now is not only the ability to manually input the frame number that you wanted on, rather than having to drag it on the timeline, but also manually input the X and Y position at that keyframe. So if you want precise control over over where the object is at that keyframe, you can type in the value here and it will move to that position. And you can move the keyframe as well, so that's just a little bit more accurate control over setting up your animations if you want them very specific, rather than having to drag them around here and use keyframes that way. And the next one is related to debugging. So if we go to let's go to our object and see, I think the bullet has some logic on it. So if you recall, the debugger in the preview simulator allows you to set breakpoints. So if I set a breakpoint on there, you can see we've got a symbol to show that that's on a breakpoint. So now if we run in the simulator, it'll stop at that breakpoint. That's how it always worked before, but in order to make this a little bit more friendly for general use, I've introduced the ability to disable and enable breakpoints without removing them. So clicking on this or back in the object logic editor and removing the breakpoint actually removes that breakpoint, so it's no longer active. But what you can do from within the debugger is you can disable and enable them. So if you disable all and then play, it'll carry on as normal, and if at any point we enable all, it'll come back again. So that allows you just to and you can do it on individual ones as well. If there were more than one breakpoint, they would all be listed here, and you can check which ones you want to still be active. So it gives you a little bit more finer grained control over which breakpoints you want to be working with at that point in time. And all of that information is also saved with the game, so it carries across from session to session. So once you've got yourself in a position where you're debugging something or you're investigating how the logic's working in a certain way, you can get back to it once you've saved and come back again. And the final individual smaller not optimization related change to Kwyll is something that was on my list of things to do for a little while, and I decided to get to it. Basically, up until this change, objects are drawn, sprites which represent objects visually are drawn in an arbitrary order. They're basically drawn in the order that they're created, which isn't ideal, and you ideally want some more control over what goes in front of other things and behind other things. So the sprite library that I use on the Spectrum allows you to do this, so I thought I'd expose it properly and implement it in the simulator. So if I load up a file that I've got saved for testing this, if I can find it, sprite planes. So the way it works is, if we go to our room in this one, I've got 4 objects, a simple player, which has a left-right controller on it, and then 3 of these bubble objects. And if we look at the object properties in here, you can see, I said before, there's more changes in here, and this is the one that we're interested in here, this plane. So basically, think of a plane as a layer that on which the objects are drawn, and the smaller the number, the closer they are to the screen, effectively. And as you go further away, they draw behind. So plane 0 will draw over plane 1. And something drawn on plane 2 will draw behind again, and so on. So if we look at this one, on this one we've got bubble. The first bubble is on plane 1. The second bubble is on plane 3. And the last bubble is on plane 0, and the player themselves is on plane 2, so it's in between. So if we play this, you'll see as you move the player, it goes behind some and in front of others, depending on the ordering, and you can control that. It does mean that you excuse me, you don't have the ability to make changes to this on the fly, so you can't move that bubble now to be behind the player. Unfortunately, that's just not something that the sprite library currently supports. I'm looking into ways of maybe supporting that in a maybe a more complicated way, but for now it's fixed at the time that you create your objects. But this does, or did, highlight a small problem in that when you create objects dynamically using the spawn node, they will always have a plane of 0, which might not be what you want. So in order to support that, the spawn object node has been enhanced slightly to add a plane. So when the spawn object is created, it will take the plane that you specify in here, or through a connection in on the port. So that allows you to define where your bullets, bombs, collectibles, anything else that you're creating dynamically, where they sit on the ordering. Okay, with that lot out of the way, I'll spend a little bit of time now going into some of the changes that I've said are underway in terms of optimization and memory use. They are on the list, so I will refer to my list to make sure I don't miss anything. So in order to support this, I first of all started by creating a simple test that would test a bunch of the core features in Kwyll that I think might be relevant when it comes to performance. I did this by simulating or emulating a particular level from Manic Miner, which had a lot of animations. So if I quickly go to the editor, and I've got this loaded, so you may recognise this, the Mutant Telephones level from Manic Miner. It's not meant to be accurate in any way, but it just basically, the important thing is it has the Manic Miner character, Miner Willy, with a simple platformer controller from the tutorial. It's got a bunch of tiles with collision detection, so that should all work. It should be able to jump around on the platforms and so on. But it also has 6 enemies, all animated with keyframe animation. So if I switch to here, you can see each one does their thing animating around. So this is using keyframe animation. I was concerned about how this would impact a number of things. First of all, the cost of doing the keyframe animation, and I'll go into why that's an issue in a moment. Also, the cost of collision detection or intersection detection between the main player and the enemies. And again, I've got some solutions for that and why that was an issue. And also the combination of detecting intersections between objects and detection collision between the player and the background, and making it all work together, and how that was going to affect the overall performance. It turned out that my concerns were reasonable. I did a first test, and I think if I'm able to switch quickly to the emulator and load up, I think I've got one. This is using the previous version before I made any changes. So you can see the movement's a little slow. It's not ridiculously bad. It does do the collision detection. There's a bug there which I've also fixed. So if you notice, when you jump here, you reach the peak of the jump before going above the platform, but it drops you up onto the platform. So that's been fixed too. That's a change in the way that the collision detection works. That's more how it should work. But you can see the performance here. You can see how slow things are moving, how slow the jump and everything is. So that gives you an idea of what we're working from. And I'll go into a little bit of detail about some of the things I've changed to improve this. So first of all, I started shuffling things around in memory on the Spectrum to try and understand a little bit more about how the memory is being used, moving the coder as far up as possible, using as much of the available space on the Spectrum as possible. And one thing that came out of that investigation was that I can only move the code up or down in memory to a certain point before it starts causing problems. And the reason it turned out was, I believe, because in order for anything to be loaded on the Spectrum, the first thing you need is a basic loader. So when you run when you load quotes on the Spectrum, it loads the basic file and runs the basic file. So when you create a tap file from Kwyll, it creates 2 files on the tape. It creates a basic loader, which is just a single line of code, loads the binary, which is the assembly, the program that actually gets exported from Kwyll, into a certain address in memory, and then runs that address. Now, because it's got a basic loader, there's a certain area of memory at a certain point in the spectrum, and I'll try and put somewhere up on the screen an image of the memory map so you can see what I'm talking about, that is used by BASIC for variables and other things about state during the BASIC. If you overwrite that while the BASIC is still running, which it is when it's loading, everything obviously goes wrong. So you can't load the main program over the area that BASIC needs, even though I want to be able to recover that much memory. So I worked out another possible solution here to be able to overcome that and recover that memory so it's not wasted, and at the same time possibly get some additional performance. And the way I did that was, it turned out that there's 704, I think it's 704 bytes it turned out to be, above the minimum address that I had to load the code into, where BASIC needs that space. That's 704 bytes, and if I tried to move it back into that at all, even by 1 byte, it crashed on loading. So there's 704 bytes there that once the game is loaded and running, the BASIC doesn't need them anymore, because I don't use BASIC anymore, and it's just lost. That 704 bytes is lost. So in Kwyll, for something like this, you can see, if I switch back to Kwyll itself, you can see where we've got these green markers here. This is the collision information in the tile map. Now I store that separately in a separate area of memory that can be queried later during collision detection in the main code. So when the nodes are trying to see whether it's possible to move a player where you've asked to move them, it uses the information stored in that area of memory to determine what the collision information is on the tiles in the map at the moment. To maximise or minimise effectively the amount of memory used, I employed a slightly more complex way of storing that data. So instead of having 1 byte per tile, because the only information you need per tile is where the top, left, right and bottom sides are impenetrable, it's just 4 states. So I figured you've got 4 bits, so I could do it in a nibble rather than a byte, which meant I could half the amount of space, which I did. So it went from 768 bytes to 384 bytes for a full screen game. And that was important at the time when I was trying to save that memory in the main area of memory. But I figured with 704 bytes of space that I'm actually losing for no good reason now, if I shifted the code down just a little bit further and free up 768 bytes up there, I could use that, and more importantly, I could use that as a byte per tile, which seems wasteful, but I was already losing that 704 bytes anyway. I wasn't getting any value out of it at all. And the important thing is, looking up a tile in an array which is byte per tile is much cheaper than looking up a nibble and shifting and masking to get the 4 bits that you need. So there was some performance improvement to be had there, which I've implemented. So that's basically moving the I don't allocate space anymore for the collision buffer. I just use that dead space above the code and expand it out to a byte per tile to make it more efficient at runtime. So that got us a little bit. The next thing I looked at was the animation system itself. So where it animates these telephones using the keyframe information here. So the way it used to work is every frame of the game, it would tick forward the frame number on each animation. So it would move 20, 21, 22, 23, 24, and then it would have to, on each object that's being animated, it would work out which span, I call it a span, of the animation the keyframe is in. So this one is in a span between this keyframe and this keyframe. So it works out that the start keyframe is that one, the end keyframe is this one for frame 20. And then it needs to work out how to position the object at that far away between these two keyframes. So that involved two multiplies and two divide calculations, one each for X and Y, which are expensive on the Z80 because it doesn't have those as native opcodes. So I looked at ways of trying to eliminate that complex math, and I found a way of doing it which is slightly more costly in terms of the memory use in the game, but for significant benefit. So what I do now is, instead of doing that divide and multiply every single frame for every single animation, I do it within Kwyll at export time. So what I'll do is as well as exporting, so if I turn off play and switch to this mode, you can see the information that's stored in a keyframe is the X and the Y position and this information for triggering events. So internally now it stores the X and Y position, but it also stores two additional 16-bit integers for delta, which are basically how much to increase the X and the Y position, or to change the X and Y position by, per frame between this keyframe and this keyframe. And then this keyframe will have a delta, its own X and Y delta, which would be how much to increase it for each keyframe, each frame between this keyframe and this keyframe. And it uses a concept of fixed point math, so it's 8 bits dot 8 bits, so 8 bits of integer number and 8 bits of floating point or fixed point fraction, which means I can have less than 1 pixel per frame moving, but I won't go into the details of that. But by doing that and calculating those deltas in Kwyll before you export, the actual operation of working out where the object needs to be for each frame is simply adding that integer, or that fixed point number, to X and Y each frame. Every time you tick the frame over, you just add the delta to X and the delta to Y and move the object to that position, taking into account the fixed point representation, which is much cheaper. And it actually turned out that it reduced the time per animation to calculate the position each frame to around about 15% of its original. So that's a significant saving. That itself made a big difference to the way that this level played. And then I looked at one more thing which was concerning me, which is the detection of intersection between these objects. So obviously, because if I play this very quickly, so I want to be able to detect whenever the player is hit by any of the enemies, and I've got some sound playing when it does that. Now, if in the previous system it would basically detect, or it would check at the end of the frame, actually it would, before a recent change, it would check every time you move an object. But I moved that to the end of the frame, so basically when you move an object, it doesn't do an intersection test there anymore. It flags that an intersection test is needed, and it does that at the end of the frame once. So if you've got 4 or 5 moving objects that you're using the move object node to move, it will still only do an intersection test once at the end of the frame, once everything's moved. So that was a win. But even then, it's still having to check between all of these objects for any intersections, which amounted to 21 in this particular case, because there's 7 objects. It would be 21 tests between 2 pairs, between two objects. Now, most of those were completely irrelevant, because we don't care in this example whether the telephones intersect with one another or not. The only thing that matters is whether any of the telephones intersect with the player. So 6 pairings should be sufficient. This one between that one, between player and that one, player and this one, and so on. So you get 6 pairings. So there was a lot of wasted intersection tests going on there, and I was trying to think about ways to address that. And the way I came up with is actually based on something that Godot itself does, which is to identify, or to provide the user with a way of saying, I only care about intersection tests between objects of this type and objects of that type. And to make it as flexible as possible, I've implemented it, again, much like Godot does, as a set of layers. So each object exists on any number of these 8 layers. So this is the phone. It exists on layer 2. But it can exist on layer 3 and 4 and 8 as well. You can use those layers how you want. But for this very simple example, it exists on layer 2, as does all of the others. All the other phones, they all exist on layer 2. And then underneath that we've got checks layers, which is another 8-bit value, a bit field, which says the phone exists on layer 2, and I am only interested in checking collisions with objects that exist on layer 1. So this eliminates the need to check for objects for intersection between the phones, because if we put each phone on layer 2 and say that it doesn't check for intersections on layer 2, it will just ignore those and skip over them. And then if we look at the minor Willie, he exists on layer 1 and checks on layer 2, so it's the opposite way around. He exists on layer 1 and he doesn't check against himself, but he will check against anything on layer 2, and all of the phones will check against anything on layer 1. So with that in place, it now only checks those 6 intersections, so it cut down from 21 to 6 intersection tests per frame. In order to sort of visualize or to understand this a little bit better, I've added a new tab into the simulator area, which will be populated with various performance metrics or performance information. At the moment, the only thing in there is the number of intersection tests. So you can see if we run now, it's showing only 6 intersection tests happening, which is exactly what I wanted before this change. And I can show you how it would have worked before. If I go back to the room and I set all the phones to 1, if I set everything to on layer 1 and checks layer 1, which is the default state when you create a new object, it exists on layer 1 and it only checks layer 1. You have to go in and change it, and this is equivalent to the previous behavior. So by switching everything back to this, we're basically mimicking what the previous intersection testing did. And you should hopefully, fingers crossed, if we now preview, see we get 21 tests. It's testing everything against everything. It's testing all the phones against all the phones and minor Willie against all the phones. So you can see how that has a saving. So rather than go through and change that again, I'll just reload quickly. And if I save that out now and export with all of those changes in place and running on the Spectrum side as well, if we switch back to the emulator and load that one in from the other directory, you should see a notable change in the speed. The jumping is a little bit more sprightly. The movement of the phones is a little bit more. It's still within the 50 frames per second limit, so it won't go that much faster, but it is a bit better, maybe around about 30-40% better. And it's also fixed the jumping bug, so it doesn't pop you up onto the platform. So we can actually play this now. If I go up here, and everything works. So that's a little bit faster. It's a little bit better in terms of performance. I'd like to get it a little bit faster still. I've got some ideas for that, mainly because it's still written in C. All the collision detection is still written in C and needs to be translated into hand-coded Z80, so that'll get us a little bit more. And I've got some other ideas to improve performance, but we're certainly moving in the right direction, which is what I wanted to do. So that's mainly the work I've been doing for this iteration, moving a little bit closer to release, and hopefully be able to get out something as a version 1.0 soon. So as always, if you want to get involved, you've got any ideas, any suggestions, pop into the Discord. It's free to join. Anyone can come along and get involved in the discussion, and you're all welcome. I take a lot of feedback from a lot of people on there, and I hope most of the people on there will tell you that I am quite responsive to feedback. So if you want to see something in Kwyll, pop along. If you're interested in taking part in the early adopters program, pop over to the Patreon. I'll link all of these in the description below. And at the very least, if you like what you see, give us a like and maybe subscribe so that you can be informed when I do new videos, which unfortunately at the moment isn't very often, but hopefully we'll start to pick up a little bit with 1.0 on the way. Thanks for joining me. I'll see you next time.